right. OK, if I had known that that was going to be announced on stage, I would have had a better fun fact, but that's all right. Hi, folks. My name is Robert. It is an absolute honor and a privilege to be able to present to such an august and distinguished group, and I really just hope I'm not going to let you down. I know you guys have better things to do. There's plenty of bars to go to, and compilers can be a little bit of a boring topic, but I promise I'll do my best to keep it entertaining. So I'm here to talk about Isograph, what Isograph is and sort of why you should care. It's, in one sentence, a compiler for your UI. And I'll also talk about why, even though you may think you don't need a compiler, you can build more robust and performant UIs with one while shipping features more quickly. So compilers, they're just powerful tools. And if you shy away from them, if you want a framework that is just JavaScript, you're limiting yourself. And you're leaving a lot on the table, and you're letting your users down. And we'll end with a discussion of where I think UI development is headed in an AI-heavy world, and why compilers are even more important now than ever before. Now, Isograph. Isograph is an opinionated, compiler-driven framework for building data-driven apps. Apps that are stable and performant out of the box. With Isograph, a compiler takes care of all the nitty-gritty details, like wiring your components and passing data around and writing queries for exactly the data that a given view needs. So let's talk about what it's like to actually write an Isograph app. An Isograph app is built up of components that also specify the data they consume. For example, this task summary needs the task title, status, and due date. These are server fields, which is to say they're ultimately provided as part of some sort of network response. Now, notice that this task summary doesn't specify how to fetch the title and status. It just declares that it needs those fields. And then it receives them as props. And what does this function do? Well, it's a component, so let's just return some JSX. Yeah, that works. Now, the key thing to note about Isograph is that the task summary itself defines a field. So another component, in this case the task card, it can select the task summary as if it was a server field. From its perspective, it doesn't really care what it is. It just gets some sort of component. And what does it do with that task summary, which is passed in as part of that first parameter? Well, it's a component. So let's render it. And that's the amazing developer experience that Isograph provides. But all the magic is in the things that we didn't do. There should be some audio. DJ, there should be some audio. Is there some audio?
Ha! You know what he didn't do?
Tell me, what didn't he do?
Give me a reason to care.
It's a bit loud. So, though I was rudely interrupted, let's talk about what we didn't do. Well, the components just declared the data that they needed, not how they received it.
I'll specify how the presentation was received.
How was it received?
Poorly.
Gentlemen, there'll be time for Q&A afterward. Please, please. Now, the parent didn't pass any data down to the child. In fact, the parent had no access to the child's data. Now, to answer the gentleman's question of why we should care, you care because this isolation lets you reason locally. You can look at one component and understand it completely without thinking about the rest of the app. Adding or removing fields from a subcomponent doesn't affect the data received by any other subcomponent, not just at the type level, but also at runtime. So developers can ship features in parallel, and there's no manual coordination or communication required to ensure that the app doesn't break. And this is what gives apps built with Isograph a level of stability that's simply unachievable in other frameworks.
Hogwash, he's saying we're doing it wrong. I've been building apps the same way since 1939, and they've never once been broken.
That's because you're shipping marketing pages with no moving parts, you old bag.
The gentleman, while disruptive and inexplicably sitting on stage, are right. the current industry standard for building data-driven apps makes rapid iteration difficult. Consider modifying the task summary card to stop using the due date field. Removing it locally is trivial, just stop using it. But now you must traverse upward to find every instance of that task summary until you hit a query root. And then you must traverse downward to discover all the other places where that data flows and see whether any other subcomponent is using that due date field. And only when you're finally certain that this is actually unused anywhere else can you remove it from the query. Now, that's one, a lot of work. I'm lazy, you're lazy, we're not doing it. Two, it's fundamentally brittle. Three, it makes it really difficult to ship changes rapidly and in parallel. So the fundamental dilemma that we have is that we can, on the one hand, prune the field and risk breaking production if we miss a spot, or realistically, we leave it. And we accept the fact that we fetch more data than we actually end up using. And so over time, our apps accrete data that's not used, and the payload sizes increase. And look at a banking app. How much of that data is actually used every single time? Probably not 100%.
I know what I'd do. I'd watch a more interesting presentation. If I could just find my walker. Why are we still here?
Now, I want to ask the gentleman a question. The question is, in your marketing sites, when you change the CSS, when you restructure the HTML, what do? Do you grep through the CSS and find all the classes and make sure that they're unused? Or how certain are you that in your CSS and that marketing site, there's no unused CSS?
I use Tailwind. I don't have that problem.
He doesn't know what he's talking about.
Well, these gentlemen are right. Tailwind solves this problem for CSS. With Tailwind, you essentially declare dependencies locally, and then a compiler scans your codebase and generates some CSS for exactly the classes that end up being used by your app. Now, Isograph is exactly that, but for data. We're stuck in the pre-Tailwind world when it comes to data fetching, and we're manually doing a lot of work that should be done by a compiler. We're not compilers, we're artists. And that kind of work it's difficult to get right. So with Isograph, what happens is that the compiler will find all the query roots. It will itself traverse downward and find all the accessible server fields. And then from there, it will generate a query. So this is great. You stop using due date in that task summary component. Well, if it's not used anywhere else, it's going to be removed from the query. And furthermore, if you stop using the task summary card entirely, well, in the old world, you'd have to make sure that due date was unused. You have to make sure title and status are unused. That's a lot of work. And it's furthermore compounded by the fact that, heck, this component might be used across multiple screens. And it could be used it could be deeply nested. And the query itself, it could be abstracted behind something like Redux. Or it could be a REST endpoint that serves multiple versions of your app, or even worse, multiple apps. That's a lot of work. Isograph does all of that for you on every single save. You save, it regenerates queries, and now you're guaranteed to have an app that fetches exactly the data you need, no more and no less.
Well, I work with REST endpoints. This sounds like you're gonna force me to use GraphQL over my dead body.
Nobody uses GraphQL anymore. Go back to 2015, you fool.
It's true. Right now, the way Isograph works requires GraphQL, because the compiler needs to generate a query on every save for all the used fields. The model is a little bit less applicable if you have custom bespoke code that just happens to return the right data that a compiler can't generate. But hear me out. GraphQL is an implementation detail, and we're actively working on lifting that requirement. So soon, you'll be able to use Isograph with SQL or TRPC or whatever you want. For prioritization reasons, basically because I'm very AI-pilled now, we haven't prioritized that, though. So anyway, there's some really non-obvious benefits to having a compiler generate queries for exactly the data you need and not requiring you to be in charge of that. Avoiding over and under fetching that's just the beginning.
Just the beginning? Please, I'm begging you, make it the end.
So imagine you have a screen with a task list and an activity log. And the activity log takes a long time to load. Maybe you're fetching it from some external provider, or there's a bunch of joins in some database. Either way, it's a really bad user experience if this entire page can't be shown to the user until everything is ready. Clearly, the activity log is less important. So the natural thing to do in a situation like this is to split this into two queries, one for the task list and one for the activity log. Honestly, not that bad, but there's some downsides. For one, the activity log might fetch the same data as the task list. It might not now, but it might in the future when you make some changes. And so that means that you're redundantly fetching that data, wasting bandwidth, and also wasting server compute. And also, you sort of open yourself up if that data changes in the few seconds between one query and the other. You might have inconsistencies in your screen. It's just not ideal. OK, so what can we do? Well, we can carefully divide this query into two subqueries and make sure that the lower query, the activity log query, doesn't fetch any of the same data as the task list. But again, that's us playing compiler. And it's fundamentally brittle. We have to do the same thing we saw on the other page, like see what is accessible from here, make sure it's not accessible from there, follow everything. No one's doing that. We are realistically doing one of three things. One, we're either using one query and accepting the user experience hit. Two queries, we're doing that and accepting the overfetching, accepting the performance hit on our server, or we're manually deduplicating, which, as I said, is quite fragile. But again, compilers, they come to the rescue. The key thing we want to know here is that we want two queries, but we need some way to know that they're linked. And in GraphQL, that's the defer directive. And in Isograph, that's the loadable annotation. So what we essentially have is two network requests that are syntactically part of one query. So you might imagine that this octopus-looking blob here represents the query, the data that you're actually fetching. And with both of these, what you do is you specify part of the query has essentially a follow-up network request. Now, this is great. Now we have the best of both worlds here. We can essentially deterministically, because by a compiler, guarantee that we're fetching all the needed data, but we're not duplicatively refetching it.
Earplugs!
What more could you want? Earplugs. OK, a little out of order here.
Sounds like you're in love with GraphQL.
In this house, we love tan stack.
You know, the gentlemen have a point. GraphQL is what enables all this. Because we can generate queries based on the needs of the UI, we can make sure to avoid overfetching and underfetching. But honestly, GraphQL limits how far we can go. I don't know if you guys were looking on YouTube, but the GraphQL Conf folks just published my talk from a year ago, or from a couple months ago, entitled, "Is GraphQL Dead?" Like, I definitely don't think that GraphQL is the be-all, end-all in this situation. Consider a task label, something like eng1234. It's the project prefix plus a dash plus the task number. The schema has the prefix, the number, and the full label. But the GraphQL schema, it also doesn't contain enough information to indicate that the prefix and the number flow into the full label. So if we have one component that uses the prefix and number, maybe it uses them separately, and another component that uses the full label, well, we'll fetch all three, even though the first two are enough. Now, I know what you're saying. We have a solution for this. It's those same client fields that we discussed earlier. In particular, if instead of that being a server field, we just describe that as a client field, well, we end up only fetching just those two fields. But OK, that's not ideal. If we're on a screen, for example, where the project never changes or the task number never changes, well, then why do we download two separate fields and concatenate them ourselves? It would be more efficient to move that to the server. Or more to the point, it might be very convenient for you to describe some piece of derived data as a client field, but then actually execute it on the server. Consider a linear style app where you have hundreds of thousands of tasks, but only 100 of those are yours. Well, that's a big input to a small output. You don't want to download the entire input just to filter it down and use the 100 tasks on the front end. You want to execute that on the back end. So essentially what I'm getting at is the vision for Isograph is that you can define everything locally as a client field, but when necessary, you can move stuff to the back end. Now,
is that all you got? Isomorphic components? Just admit you're peddling an inferior version of React Server components and let us get back to drinking our prune juice.
the gentlemen are correct. This is essentially a better version of React Server components. Not inferior, better. With React Server components, you're essentially able to server render essentially the outer layer, which is to say the UI. But with this vision for Isograph, what you're able to do is find the optimal thing to server calculate. Now, in this example, the UI is interactive. We don't want to server render that. But filtering 10,000 tasks to just the ones that are yours, that should run on the server. So we can specify anywhere in this sort of data tree that we want to move to the server. And that's quite nice because I can have multiple components locally, the task list UI, maybe some sort of badge that shows how many tasks I have, maybe some other summary version of this, that all use that same server rendered field. Sharing data like that with React Server components, it's a bit awkward. It's not the best user experience, but this allows you to specify exactly what you want to server render. And that's the direction we want to go. So imagine I have two components. One shows a badge in a sidebar that we have 3 overdue tasks, and the other shows the actual list of overdue tasks. Now, these are both client fields, and they take my tasks and they filter them to the overdue ones. That's an expensive calculation, and it's shared in both. But the way we were talking about client fields, that actual calculation, it happens in some opaque JavaScript function. And the compiler can't see that. So it runs the same expensive filter twice. That is, unless we extract my overdue tasks into their own client field so that both components depend on. That gives us that great performance that we actually desire.
Wait a minute, isn't that playing compiler? I thought we weren't going to do that.
The gentlemen are right. That is playing compiler. And we shouldn't need to do that. So actually, the direction that I want to take Isograph is as follows. Instead of having this completely opaque language, JavaScript, that can do anything that's very difficult to analyze, and also instead of having this very limited language, GraphQL, where there's only one thing you can do, which is merge selection sets, what if we had something in between? Something that is strong enough to specify, hey, take this list and filter it down, but still statically analyzable by a compiler. So imagine this. Now, if we had that, we'd have 2 huge wins. First, the 2 components that use that same filtered list, when the first one executes, it'll calculate the filtered list and it'll store it in the cache. Then when the second one executes, it'll check whether that filtered list exists in the cache, find it, and reuse it. So we get essentially a free performance boost. And second, and this is the one that really matters, we can actually short circuit. So say you modify a task, you change its title, change its due date, whatever, but it wasn't overdue. In the old world, if we didn't extract anything into its own client field, the list of tasks changed, so we'd have to recalculate everything downstream. We just don't have the information to know that we don't use the not overdue tasks. But in this world, we would rerun that filter, that cache item 1 circle that you see that the filtered list, the result of that is unchanged, and then short circuit everything downstream of this doesn't need to recalculate. And so the badge doesn't re-render, and the list doesn't re-render. And that's essentially a great way to build apps that have unlimited complexity, but actually still only execute the changes that need to happen. And incidentally, this is actually how the Isograph compiler works under the hood. When you make a change to an Isograph literal, it will calculate the minimal number of things that need to change. So it's a doable model. Now listen, this new language, it's not in Isograph yet. That's definitely the future. But this language does exist. And it's called Barnum. Barnum is a programming language for working with asynchronous and parallel computation. And what's the #1 example of asynchronous computation that everyone's talking about right now? That's right, agents, orchestrating agents, invoking LLMs. And the goal of Barnum is to make it easy for you to orchestrate your agents. And it just happens to have the added benefit of being the right thing for Isograph as well. So let's take a look at Barnum.
Sounds like a few developers that I know. Ho, 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 ho.
That was out of order. What I meant to say was, the thing is, LLMs are great. They're incredibly powerful, but they cut corners, they forget the rules. When the context fills up, they start getting forgetful. And they're inherently limited. Our ability to build abstractions on top of them is inherently limited by the fact that they're probabilistic. And frankly, the era of cheap subsidized tokens is rapidly coming to an end. So what we want to do is to move as much as we can outside of the LLM's hands. Not because LLMs are bad, they're incredible, but because every token you can avoid spending on coordination, on control flow, on do this thing, is a token you can spend on reasoning and actually hard problems and solving the things that only LLMs can do. And this makes your LLMs more efficient, fewer tokens, more reliable, less room to go off the rails. And honestly, unless you're GitHub, you need several nines of reliability if anyone is going to use your product. So you absolutely cannot build reliable tools off of something that could just decide one day, hey, I don't know about this. So the way Barnum works is as follows. You define a pipeline, in this case, in TypeScript, and it's just a description of the work that needs to get done. This gets serialized and sent to another process that actually ends up executing it. And the leaf nodes are exported JavaScript functions that can run in their own isolated environment. And asking an LLM, invoking an LLM to do something, that's just another leaf node. There's nothing special about it. So essentially, the language is focused on all the control flow aspects, and then you implement whatever details, whatever you need in those leaf components. So now, listen. I have an absolutely massive announcement. As of this morning,
Oh, please, are you ending your presentation early?
Maybe there are free grape nuts for everyone.
Not quite, not as exciting as that, but as of this morning, another version of Barnum has been released, version 0.4. So I really encourage you to go try it out. I've already been using it internally to ship hundreds of PRs without breaking production. Folks have built a RAG pipeline using it. Folks have used it to analyze all of the statements in documentation and evaluate whether they are truthful. And folks have used it to do incredible things, remove dead code. Basically, the point of Barnum is as follows. If you write a bunch of logic in some sort of markdown file, one, that's not really composable. It's really hard to say, I want to add this retry logic to this thing and then also use that elsewhere. That's not good. And secondly, the optimal amount of infrastructure around this is a lot higher than you typically use. Imagine asking an LLM to implement a feature. Well, you probably want the LLM to implement the feature. You probably want another LLM to review it and make sure that there are no security issues. You probably want another LLM to review it and make sure that it actually did what you asked for. You probably want to run TypeScript and run unit tests, and you want to guarantee that those get run so that the LLM shouldn't be able to disable those. Then you want to loop that back all around until everything is clean, but you also want retry logic in case something times out. But you also want to limit the retry logic because, well, if the system is down, you don't want to do this forever. If you're writing that in a markdown file or worse in a prompt, like, good luck. Maybe you like writing essays, but I like writing things that I can understand and I can reason about. And that's how, using Barnum, I was able to ship hundreds of PRs in a particular week, about a month ago. And it's great. It's just, you spend a little bit of time programming and you get 100 times more value out of these LLMs. Now, that's my presentation. I want you to think about this. The takeaway is this. Compilers are here. They're incredibly powerful tools. And if you're not using them and you're doing stuff manually, then you can't have the stability, you can't have the performance, and you can't have the ability to ship features as fast as you otherwise would. You really need to be using the strongest tools, because otherwise LLMs are going to do our jobs. We need to level up. So with that said, I encourage you to try Isograph. I encourage you to try Barnum. And start the repositories, join the Discords. Go ahead and give them a try.